Hi po, uh, good evening.
Hi, good evening, sir.
Hi,
Welcome po sa OGS.
yeah, thank you. Yeah, so good, good evening, everyone.
Good evening.
Yes. So welcome to transportation modeling. Today we're going to learn about traditional method. Okay. And then you can follow this in Moodle, the slide. Before that, how about the assignment last time? Have you done it? Is there any difficulty about the assignment last time? Is there anything you want to discuss about it? No, you see, right? You just fill in the number and then you just compute in Excel. So there is no real problem there. Okay, so I will share the screen. So this is my screen. So you go to Moodle. Okay, so we are in this topic of transportation demand analysis. Can you see? Okay, so let's go to the first one, which is traditional transportation planning. Okay, and you will have assignment here later. Okay, okay, let's start. Okay. So this is the topic that we will discuss today. Okay. Forecasting versus planning, and then the detail, yeah, the modeling, okay, of growth factor, and then using linear regression, okay, nonlinear regression, and then multiple linear regression. Okay, and time to time I will also discuss about trip generation later. Okay, this is the plan. That first. So what's the difference between planning and forecasting? So when we say planning or forecasting, yeah, both are about predicting the future, isn't it? Right. So both also based on previous data, okay, and both also have assumption and invariance. So what's the difference is actually this one. Yeah, forecasting is actually passive, okay, objective, that we will predict what will happen in the future without our intervention. Okay, when we say planning, that means we are active and subjective. That means we guide what will happen in the future based on our action to control the path to achieve our objective. Okay? So to do planning, you need forecasting, right? So you cannot do planning unless you know how to forecast. That's why what we will learn today is about forecasting, very basic forecasting. So planning itself is a process, okay, to examine the potential future action, right, and to guide the system toward uh, your desired direction. So as a planner, these are the common desired direction. Yeah. So UTP or urban transportation planning is a process to prepare the physical facilities and services of all mode of future transportation needs in urban area because it's urban. Eh? So in order to provide, this is the desire, to provide safe, okay, rapid, comfortable, convenient, economical, environmentally compatible, and efficient access. Okay, and mobility for people and goods. Of course, the the main purpose is to satisfy human needs. So, transportation planning itself is a multidiscipline. Yeah, you will see, you will learn, you already learn. Yeah, so social science, economic planning, architecture, system engineering. Probably part of you are civil engineering. We will also use math and statistics a lot. Okay? And going here, going to the physical science. Okay, going. This is the overlapping between transportation planning and traffic engineering. Okay. There's also overlapping with transportation engineering, which also learn about geometric design and soil pavement design. So transportation planning is in this region. So, and open transportation planning process usually have this schema. Okay, first you have the goal and objective I already mentioned earlier, and then this is the organizational. Okay, usually you have a policy and technical. So we have also citizen participation. Okay, that means every planning that you have, that you need to present it to public before you are going to implement that. And then, of course, you collect the data. Usually, this is the data that you collect: population, economic activities, okay, land use, transportation system, travel demand usually, and then the terminal transfer facilities, okay, traffic control, law and ordinance, finance, and community values. Yeah, so these are the data that you usually collect, and from there you do what is called analysis. Yeah? So this is traditional process. So we calibrate the model of land use, we calibrate the trip generation, trip distribution, model split, and traffic assignment. So today we'll probably just learn about trip generation. Okay, next month, okay, after your midterm, you will learn about trip distribution, modal split, and traffic assignment. Okay, and yeah, so for each of these variables, population, land use, economic, travel, and revenues, you need to forecast. Okay, and then based on this forecast, then you analyze the future alternative, the alternative scenario. Okay, what are the scenario that you can overcome? This is the planning part, no? So that you will intervene. Right? You will intervene based on the forecast. So uh, again, the same model. We use the land use model, trip generation, trip distribution, model split assignment, and then you plan this, okay, and then evaluate and select for planning. Once you implement this plan, okay, this is what people often forget is actually monitoring. Okay, so you need to do surveillance again, reappraisal, okay, and then check again whether what you plan and reality is actually the same or not. Okay? If not the same, then again you need to intervene. Yeah? Okay, so this is a continuing process. You see, it's a loop. Come back here again. Okay. So up to here, is there any question? Okay. Okay. So the core of our analysis in transportation. Yeah. So land use model you will learn in other course, right? So in this course, we will discuss about this four. Okay. What is called trip generation, trip distribution, modal split, and traffic assignment. So these are the four-step model of a traditional transport model. Okay? So we call it classical demand forecasting model. So it has 4 steps. The first step is called trip generation. Okay, so based on economic activities and population, okay, you get the trip. Okay, of course, based on the trip purpose. So you get the trip attraction or trip production. That means how many people will go from certain place to other place. Okay, or basically, trip generation means how many people will be generated in certain area or will be attracted to a certain area. See, generated is usually for residential area. Okay, so how many people will go out from this residential buildings or residential area, and then attraction usually other activities like shoppings, okay, office, and so on. Okay, so trip generation basically get 2 vector. Okay, what is called trip production and trip attraction. Trip production is how many trips. Okay? Here is person trips. How many person trips is generated per time? So time period will be 1 day or one week or 1 month. Okay? So it's a flow. Okay? In certain area for certain trip purpose. And then the second steps, okay, is the choice of destination. Yeah, from that point of origin to that point of destination, how many person trips per given time? So this is called trip distribution. Yeah, this is based on the cost usually. And then the third step is called modal choice. Okay, the travel mode. Okay, this is a person trip that we have earlier. So what is their mode of transportation? Are they using car? Are they using motorcycle? Are they using bus? Are they using MRT probably or jeepney? Yeah. Or are they walking or bike? Okay, so these are the model split model. Okay, the last part, okay, this is the most important, is what is called network assignment, yeah, or traffic assignment. So this is the choice of route or the path, okay, where they will pass. And then finally, at the end of this all model, okay, you will get link flow. Okay. How many flow or in terms of PCU per hour in each link. So these are the whole process. Okay, so this is the purpose of transportation demand model in general. Okay, so your goal is to predict the future traffic volume link flow from the origin, okay, to destination by certain user group, okay, for a certain trip purpose, okay, using certain mode at certain route at certain year. So these are the real goal. Yeah. So let's do it one by one later on. Okay. So that you can see how we will do this objective. Yeah. This purpose. Okay. So now I want you to learn what is called basic forecasting. This is really basic because without this learning, okay, you will not be able to understand the next topic. Okay, so let's start with this. Yeah. uh, for the simplified urban transportation planning process, yeah, we have already discussed, okay, transportation demand and then transport supply, right? So again, the technique is to have a regional population, land use, and economic projection. So you do forecasting, usually in traditional method, we divide, okay, the whole city or the whole region of interest in the zone. Okay, so this zonal usually based on administrative region because each of the administrative region have statistical data. right? So for example, statistical data is economic statistical data and population. These are the main variables that you can use. Okay? And other data for each building, you need to know the floor area and so on. So based on that, you can detect. Okay, and then of course you also need to know the specification of highway alternative. Based on that, you can calibrate the travel demand forecasting model, which is the four-step model a while ago. Or later we also learn about IFN. We can also forecast the same thing. Okay, and of course you will forecast the resulting target year. Okay, for user level and user benefit. Okay, and then estimate the cost and evaluate the alternative. Yeah? From there, you can select which project to be implemented. Okay, these are the common process in urban transportation planning. Okay, so let's start with first model. This is very simple. Okay, this is called growth factor. Okay, so let's say P is any variable that you want to use. Yeah? Either maybe the volume of the car registration, or the price or population is up to you. Okay, and then time is also discrete. Okay, so uh, this is how you interpret the notation. Okay, first, if I put P here, say I said price or population, yeah? PT, that means population this year. T mean time of this year. So T minus 1 mean yesterday or last year or last week. Okay, so depending on the time frame depends on you. Okay, you can define time frame as daily, weekly, monthly, yearly. Is up to you. Okay, so that's why I put here price yesterday or population last year. So this is the different time frame, or price today and then population this year. So if you use population, you use yearly. You use price probably in the stock market, you can use daily or hourly. It's up to you. Okay? So again, the variable P here I just represent as price of population. The variable is up to you. Okay, can be flow, can be number of vehicles, can be population, and so on. Okay, so the most important here is this is a variable. So P is a variable, and then this is the time. Okay, the time is discrete. So if if we say T plus 1, that means the next time step. Yeah, that means tomorrow or next year. Right? So this is the growth factor, or what we call return. Okay, the return of today, okay, is the same as, say we use population. So population of this year minus population of last year, okay, divided of last year, right? Then this is the simple formula. So this is in percent. Yeah? If you just put the numerator here, this is the change, right? So you divide by certain things, then become a unitless because they are the same unit. The nominator and the denominator here is the same unit, so you can put it into percentage. Okay, and how to forecast? To forecast, you need to uh, assume. Okay, to forecast, you need to assume. So I put here a while ago. This is the formula. You look at this carefully. Okay, look at this. T, this is T minus 1, right? And then this one is T minus 1 and T. So then I will add with 1, okay? So if I add with 1, what will happen? So if I add with 1, this one become T plus 1, this one become T plus 1, and then this can become T, right? Here also become T. So this is what I write here. Okay, so we add with 1, that means I want to forecast, yeah? So then you need to assume, yeah? These are the return or the growth this year is the same as next year. Yeah, so this is what we call invariant. So we assume they are the same. Of course, when you assume the same, then the two formula above we can put them together. With that easy, yeah. So PT plus 1 here is 1, right? So you can just multiply, cross multiply here, RT with PT, right? And then this one we go to the left side. Can you see? Okay. Then we simplify. So we have this formula. Is the growth factor the same as traffic growth? Yeah, you can use this for traffic growth as well. Okay. So the variable here is up to you. Yeah. You can use P for traffic growth. You can use P for volume of the flow, or you can use it for car registration or population. Is up to you. Again, the variables, you are the one who decide. Okay, so this is mathematics, so it's general. Okay, let's practice, okay, so that you can understand this. So, okay, this is the practice. Okay. Can you compute the growth factor? Okay, so I have the simple data here. Okay. Population 2.1 million, 2.9, 3.2, 4.1, 4.9. Yeah? And then you need to forecast 2025. And probably we continue, yeah? 2026 and so on. Can you do it? Okay. Okay, let's do it together. So let's open Excel. Okay. Yeah. Can you see? So this is, you type. Okay. So I will put here. This is the yellow. That means you type. This one also data. So you type. Because this is, okay. So the first one, you don't have the growth. Oh, the first growth is this one. This mean, okay, I type it in column C, right? So you can do the same. That means you get the growth. What this the second, yeah, is row 5, C5 minus C4, okay, divided by C4, yeah. So remember RT, yeah, equal to what? PT minus PT minus 1, right? Divided by PT minus 1, right? So, okay, so I will put this in the correct font. This one is also subscript. And this one also subscript. And this one also subscript. Okay, now we get a good formula. Yeah, so the growth here, RT, right? So is the current, which is 2.9 here, minus the previous, okay, and then divide by the previous, yeah. So this is exactly this value, okay. And then if you use the formula to forecast, right? So you get PT, right? So this is easy, right? So the previous multiply by 1 plus the growth, yeah. Yeah, this is just the same formula, yeah. It's just reverse. Yeah, you want to get PT, right? assuming you know the growth. But to get the real forecasting, you need to assume that RT is equal to RT plus 1. Yeah? So what happened is, this is what you calculate, right? Okay, this is what you calculate. Did you get until here? Anyone? So then how I will forecast here, right? So to forecast here, if you put, what is this 4.9? But this is wrong because this one have no value. Yeah. So this one must be the same as previous year. Okay. So then you know this is the result. Yeah. The forecast is 5.9 million. Okay. Again, using growth model. Oh, now my question: how about the 2026? Hmm? How do you get the value? Yeah. Anyone?
Prof, do you use the forecasted value for 2025?
No. This the you don't know yet at this point. So yes, yes. Later on you can copy this one, right?
Mhm.
Okay, and then what do you copy again? This one. Huh? So you copy again this one. So you assume the growth factor does not change,
Mhm.
right? So then you copy this one. Okay. Again, if you want to copy 2027, yeah, again the same thing. Yeah? So you copy this one here, right? And then again you copy the growth factor does not change, and then you can get the next forecast. Is this correct? Well, not necessarily. Why? Because we assume here. This is what we assume. So the last growth factor matters so much, right? Then you said, okay, I don't like the last growth factor. I will average all the growth factor. That's fine. Again, you assume something. In any forecasting, remember there is invariance. Okay. The assumption is the one that matter. So you need to expose your invariance in order to communicate with other people. Okay. Okay. Up to here, is there any question? Have you done it? Too easy or too difficult? Okay. Give me feedback. Give me a question so that I will know that you understand this or not. I guess you already did this in your work. All right. Okay, so let's go to the slide again. Okay, so this is what we have, right? So this is the result. So you can forecast. Yeah. Okay. So remember the three level of modeling. Do you remember we discussed this last time? Okay. Number one, yeah, level one is to understand the phenomena. Okay. And number two is to do prediction forecasting. Okay. Number three, okay, planning. You need to control, right? Based on your uh, output and the model, you can estimate the input. Okay. So let's go to the next model, which is called regression. Have you learned about regression?
Yes, bro.
Okay, some of you have learned, some of you probably don't. Okay, so regression is just modeling technique. Okay, we call this nowadays we call this supervised learning. The term. Yeah. So regression is modeling technique. Okay, to relate dependent. Why? So I will put the pen here. So the y is a function of x. Nah? Okay, so the y, this one is the y is output. Okay, the x is input. So you have many input. You can have x1, x2, and so on until xp. Yeah? So these are the input x. The output is a function of input. Yeah? The output we call it dependent variables or response. Okay, the input we call it independent variables. Okay, or explanatory variable or predictor. Okay, so imagine that the system is basically the same. Nah? So system have input x and output. Okay, so let's call this E as system. Okay, now a system is called linear. Okay, a linear system. It satisfies two conditions. Okay, number one, if the input is added to, yeah, if two input are added, then the output, okay, as if you can add. Okay, and then the second, if you receive, if your input is multiplied by a constant multiplication rather than zero, okay, then again you can put out the constant. Okay, so if you have this two conditions, then your system is linear. Okay, so in that case, we can summarize the two conditions above, okay, into one condition. Okay, so linear system is a system that produces output equal to the linear combination of the input. You see, now I have a new input with this linear combination of the two input, x1 and x2. Okay, and then each of these x1 and x2 I multiply by a constant a and b. Okay, then if it is linear system, then you will have like this. Nah? The output is can be put as linear combination also. Okay, you see that? So usually the graph of linear system is a straight line. Okay, so then when we said linear regression, okay, it's a linear in parameter but not necessarily in variables. So example, okay, here this is x squared up to xp. Right? This is also called linear regression, even though this is not actually linear in the variables. Okay, and many of non-linear can be also transformed into linear model. So these are the one that we will discuss today. Okay, so this is an example. Okay. Oh no, this is a practice. So which is the following is a linear regression. And if it can be transformed into linear, okay, then they are linear regression. So which of the following is linear regression? Can you encircle? The first one is linear regression. No, the first one is called simple linear regression. Yeah? This is called simple linear regression. Yeah? So the last one here is called multiple linear regression. In fact, all of these, okay, are linear regression. Okay, they are nonlinear in variables, but they are linear in parameter. Okay, I will show you later. Okay, during the discussion. about non-linearity. So you will see that they are actually linear regression. Okay, all of them. Okay, so let's discuss the first one. This is probably already learned. Okay, this is called simple linear regression. So there is a linear relationship between the independent variable, which is the input, and the dependent variable, which is the output. Okay, and the formula is rather simple. You have the y equal to slope multiplied by x plus intercept. So this is the intercept here. Okay, and this is the slope. Yeah? Slope, right? Okay. So there is some error, okay, between your data and the model. That's fine. Okay, and you will form a straight line in the XY chart. Yeah, you probably learned this already. Okay, let's do this in regression. This is the same data, I just changed the year. Can you do it in Excel? Okay, so let's go to the basic. So we have 5 data points. Okay, we want to predict the next point, isn't it? Okay, unlike the growth factor a while ago, okay, we want to predict this data, to predict the next data based on the previous data. Okay, so what will be the best model? So the first thing you do is to plot this. So this is the plot. Can you see? Can you plot this also? Okay, so if you look at the plot, okay, you will see that this look like a straight line, isn't it? It look like a straight line. So then probably the straight line will be the best fit here. Yeah. Okay. So hey, there are so many straight line we can put here, right? So which one is the best fit? Is it the blue one, the green one, or the red one, or probably something else?
The red, sir.
Huh? Yes?
Red. The red.
The red? Why?
Because it's nearest to intersecting all the dots.
Minimum ano
Nearest.
sir, deviation, parang sir, minimum deviation from the line.
Okay. So, well, everyone can argue. This one is said, oh, the blue is the best. No, I fought for the green. Okay, I like the red. Okay. So which one, right? Then well, what is the best model? Okay. The best model depends on the criteria. Yeah, it depends on the assumption. Okay. So best is actually depends on our assumption. Okay. So okay, what's the argument for the best, right? So the blue one, okay, the argument said the blue one passed through the first point of the data, which is true, right? So and then the green one is in the mid of all the data points. And the red one passed through the most point of the data. So these are the argument. But are they really good criteria? Right? So that's the question, right?
Sir,
So
I like
we
the
need yes.
I like the reasoning of the other one that says because I said so, it's the best.
Okay, so we need to have a more objective criteria, yeah. It's okay, that can be measurable from all the data, isn't it? In that case, we introduce what is called error. Okay, so let's define what is error. Okay, depending on how you define error, we will have different regression. Okay, so let's define error as the discrepancy between the model, okay, as the predicted of the data, and the real data point. Okay, so this is a more objective criteria, isn't it? So how do you measure the error? Okay, so here is the measuring of the error. Okay, we will put positive. Okay, when the point of the data is above the line. Okay, and then if the line is above the data, the error will be negative, isn't it? Right? So then let's do this. Let's sum up all the error. Okay. Well, it doesn't work. Why? Because if you sum all of the error, okay, it will just give you zero error. Right? To make it not zero, then makes our agreement that the best line model should be minimizing the sum square of error. So we square the error to make it so that the positive will not cancel the negative. Okay, so by assuming this, okay, when we said the best line model should be minimizing the sum square of error, in the back, this is actually we assume okay, the error are normally distributed with zero mean and constant variance. This is the basic assumption of regression. Okay. So then we calculate, okay? So we can calculate based on the square error, right? The data compared to that points in the line, yeah. And what we get, the blue and red and green, okay, and then we sum the sum square of error as SE. Oh, the minimum is the red one, yeah. You are right, yeah? The red one is correct, yeah. Okay, lucky. Yeah.
It was also a lucky guess.
Yeah, lucky guessing. Okay, 0.09 in this case. Yeah. So, well, if you don't want to create lucky guess, then you can use formula. Okay, you can use the formula without guessing. So this is the formula, which is the slope. Okay, y predicted is the slope multiplied by the x. This is the input plus the intercept, and these are the formula for the slope, and this is the formula for the intercept. Yeah. Not sure you want to do it. Okay, let's. If you see this one, this formula look like uh, offending you because of the sigma notation, but this sigma notation mean just sum. Okay, so how you will do this is you get it first here. Okay, n is the number of data. X, y mean you multiply x and y. Okay, sigma x mean you sum all of the x, sigma y you sum all of the y. Sigma x square here is mean you square first the x and then you sum. Here mean you sum of the x first and then you square at the bottom. Okay, this one means you get the average, yeah, x and y. Okay, so I will show you. Okay, if we want to use this, nah? Do you want to practice this or? Okay, if you want to practice this is what you need to do. Okay, so first you get the x is the input, right? The year, y is the population, isn't it? Okay, so what you will do, multiply, yeah? So 1980 multiplied by 2.1, so you get this one, 4158. Yeah, x square mean you just square this 1980. Okay, and then oh, this is missing one column here. Okay, missing one column. So once you have this, okay, you have x squared, x and y, right? So then you get the average. The average is just the sum divided by the number of data, which is only 5, right? So 1990 here is the same as 9950 divided by 5. Yeah? The same thing with 3.44 here is the same as 17.2 divided by 5. Okay. Once you have that, okay, you multiply. This is n is number of data. Can you see that I have the sum of xy, this is this one, right? And then the sum of x, this one. and then the sum of y is 1. Okay, and then at the bottom here I have n, the n is 5, and then the sum of x squared is 1 from here, and then the sum of x is 1, 9950, and then you square it. Okay, then you get this number. Okay, and then to get the intercept, you get the average minus the slope, the one that you already computed here, and then get the average of the x, and then you get this value. Okay, so once you have this value, okay, so you need to get the y predicted. Yeah, so once you get the y predicted, you minus with the y data here, you get the square error, and then square it, you get square error. Okay, and if you have the y minus this y average, you get the square mean difference. Is it clear or not? So once you have this table, okay, then you can predict. This is the model that you have. Population is slope multiplied by the input, which is the year, plus of the intercept. It is negative 267.2. Is there any question to here? So how to predict? Easy. Yeah? You just input the year, right? Okay. So X is the year. So if you want to input the year 2005, then you can just input the year, then you can get the population of that year. Okay. Okay, let's do it in Excel without table. So without table, you can do it very easy in Excel. I will share the screen Excel. Let me share with you. Okay, this is the data that we have a while ago, right? The same data, no? So I create a new sheet here. Okay, and I format it so that you will see this is population, right? So what you will get is slope and intercept, right? So in Excel you have function already. So you have slope is slope, yeah, SL and there the slope. The slope need to have the known y and the known x. Okay, the the y is actually the population, right? The x is actually the year. Okay. Okay, so this is the x and this is the y. Is that correct? So in here I have the intercept. Again, you use intercept. Again, the known y and then the known x. So this is the now if you want to predict, okay, so this 1 plus 1. So here what you will get now depends on x. X is the year. So in this case, I have the slope. Oh, let me call this slope. Slope. Okay, you put here the slope, and here is the intercept, right? So I give name in intercept. Okay. So then what I will have is the intercept plus the year multiplied by the slope. Can you see? Okay, so you have this, and this is the result. Okay, so if you want to plot, okay, just plot it. and insert plot okay. So if we want to separate the plot between the data and the forecast, right? This is the forecast. Forecast, right? So if you want to separate the data and the forecast in the plot, okay, so then you can have the chart, select the data again, so you add, okay, this is the series name is the forecast, the X is the same, and the Y here is here, the whole data. Okay, and click OK. There. Now you separate the data and the forecast. Clear? Clear? Done. So, so this is using regression. So I will here regression. Okay. A while ago, the same data, okay, we use growth factor, right? So growth factor, okay, and the result is not the same. Yeah? The result is not the same. So put here. So these are the forecasts. Okay. So if you want to separate, I will insert. I need to insert all over here in order to separate. Okay. So this is the forecast. Thing. Okay, so now you can plot. So, based on the forecast based on regression is not the same as growth factor, but they are still going up. In here, the growth going up is linear also. Okay, any question? No question, yeah? Because you already know. Okay. So let's continue then. Continue. Traditional method, yeah? So you can actually guess, yeah, to select any model, okay? Not necessarily linear model, right? Okay. So first, you use the scatter plot XY to check the fitness. Okay. Then you use more scientific way to examine the goodness of fit. Yeah, we can use the statistic for that. Yeah. So in linear regression, yeah, in simple linear regression, you have this formula, right? You can also use mathematics. Yeah. This is called ordinary least square method. So we check the difference between dependent variable and its estimation. Okay, and then you square it, okay? And then you the sum. Okay? This is basically the SSE, the sum square of error. After that, you want to minimize, right? So if you want to minimize, that means you take the partial derivative to each parameter and equate it to 0. Yeah. So SSE divided by alpha per 0. So this is an example. So instead of linear regression with a simple linear regression, yeah, we use a simple model which is only y equal to bx without intercept. So you cannot use probably, or you can still use this in Excel. So say with this, what we have is we calculate the sum square of error. Okay. And then we take the first derivative to 0. Okay. And then you solve this algebra, you get this equation. So, okay. So as practice, you can also use this on your own, yeah, to do regression. Yeah. So this is the computation. Okay. So question is, how good is our regression? Okay, so 3 things that you need to check. Okay, whether the regression is good or not. 3 things. Number 1 is the R squared. Number 2 is F statistics. Number 3 is the T statistic. Okay, as good rule of thumb for fitting linear regression, the R square must be larger than 0.8, and then the absolute value of the T statistic must be larger than 1.96. Okay, so the model must have relevance, causal relationship, to be interpreted correctly, and then the sign of each parameter also must be correct. Yeah. So to check the overall fitness of the model, you use R square and F statistic. Okay, and then the T test is to remove the redundant variable or weak variable. Okay. And then what is R square? R square is basically a while ago, the one that we calculated already, which is 1 minus SSE divided by SST. Yeah? SSE is the sum square of the error. Yeah? SST is the value of the output minus the average, and then you square it. Yeah? This is the one that in the table a while ago. Right? So if you use this in the table a while ago, right? So you can see we use this table to calculate the R square, yeah? Which is 1 minus SSE, yeah? This one divided by SST, yeah? So some square difference. So you get the R square. Why I'm talking about this? Okay, probably next time we discuss about logistic regression. This not exist in Excel. Okay, then you are asking how to get the R square. Yeah, actually the same method. Yeah, you still need to calculate the square, some square of error, and then some square mean difference, and then you use the same formula to get the R square. Okay. Okay, so if you have many variables instead of just one, okay, for example, multiple linear regression, then R square is not good enough. Yeah? Why? Because the more variable that you can put, the R square become very high. Okay, the same thing with the number of data become very high, the R square become very high. So you need to take into account these 2 values. In that case, we adjust it. So we adjust it instead of R square is the SSE, the sum. So we calculate based on the mean. So mean square of error is basically SSE divided by N is the number of data, minus Q. Q is the number of variables. Okay. And MST is the same as ST a while ago, but you adjust it with N minus 1. So then you will see that this is the relationship between the adjusted R square and the actual R square. Okay. So as the rule of thumb, okay, the R square or the adjusted R square must be higher than 0.8, yeah, to produce good linear model. Now, if your R square is less than 0.5, you probably need to check other model rather than linear model. Probably your model is non-linear. Okay, So with that, you can also calculate what is called standard error. It's basically the square root of the MSE a while ago. MSE is just the sum square of error divided by n minus the number of variables. Yeah. This including the number of variables is include the constant. Yeah. So then F statistic, okay, is based on MSR divided by MSE. MSE is the same as a while ago. MSR is computed by this formula, SST minus SSE divided by the number of variables minus 1. Okay. With this, you can get what is called ANOVA, yeah? Analysis of variance. So this is the table. The meaning of the table is like this. Yeah. So you have this value. So you can get all of this in Excel. Okay. This is the formula to get the t statistic. Yeah, it is the slope divided by the square error of the slope. Okay. Again, the most important for you is the absolute value of the t statistic. Okay, must be larger than 1.96. Yeah. Why 1.96? This is the value in the normal distribution to get the error 5%. Okay, so this, in summary, this is the goodness of fit criteria for simple linear regression. Okay. Number one, the R square must be bigger than 0.8. Yeah? The significant F from the ANOVA must be smaller than 0.05, 5%. And then the absolute value of the t statistic must be larger than 1.96 for error 5% or 1.645 for error 10%. Yeah. So using Excel, you can get this value. Let's check. Can you see my Excel? A while ago, right? This one. Okay, to do it in Excel, what you need to do is go to option here, add-ins. Yeah, you open the add-ins there. Okay, and then you go here, and then you go to analysis toolbar. Yeah, this one. And then click OK. So once you have that, okay, in your data you will have this menu, data analysis. Okay. So when you click this data analysis, yeah, so you will go to regression. All right. So the input J range is this one. Okay, this is the data. Input X range is the year and here. So 24. Your data have label. Okay, so let's check you have 95 considered interval. Let's plot everything. Okay, let's plot everything so that you will see. And then you click OK. Ta-da-da. Okay. So here, this is how you interpret this result. So many numbers, right? So what you need to interpret this result is just check this one. Yeah? Adjusted R square here must be larger than 0.8. Oh, okay. Yeah. And then the significant F here must be less than 0.05. It is okay also, right? Okay. This one also okay. Yeah. And then this one. This is the T statistic. Yeah, this is the two numbers that you need to check. This one must be, the absolute value must be larger than 1.95. Yeah. Okay. So this is to check whether your plot is actual normal distribution or not. The most important is actual residual. Of course, we have only 5 data, so you cannot see anything here. But if you have many data, then you can see the residual is actually normal distributed. Okay. Okay. So up to here, is there any question? Can you do it? Am I doing it too fast or you can follow? Or too slow? You already know. Give me feedback. Come on. So 3, yeah. Number 1, the R square, you check, okay. The F statistic, the significant level, and then the T value. Okay, this is important. Okay, so using Excel, you can do that. So, and most important is to understand which number you need to check, right? So once you know that, then easy. Okay. So come back to the slide. No question mean okay, right? Supposed to be. Yeah, the same, no? Anyway, I have the text there in Revolut 2. There is a text tutorial. You can check. Okay, and then also have uh, the slide. No? So in Excel, you can. No, so this is the 3 things I asked you to do. Okay, number 1 is check the R square. Okay, significant F must be smaller than 0.05. And then these 3 statistic must be larger than 1.65 or 1.9, yeah, depending on the error level that you set. And this is the coefficient that you get a while ago, the intercept and the slope. Okay. So yeah, you can check my tutorial, so you can use all of this. And of course, without this, you can also use the Excel graph. Yeah. So you can also use the Excel graph. Get into the screen. Okay. Where is you? Okay. Can you see my Excel? Yeah. So you click this point of your data. Okay. And then you do right click. And then you check the trend line here. There. This is the regression. Yeah, the same. So you can also use non-linear here. Yeah? So then all you need to do is to set the intercept, set the equation, and the R square. Oh, what happened? Oh, this is the intercept. Yeah? Intercept is no set intercept to 0. No. Okay, set intercept to 0 is not. Okay. Then you can get this regression. You see, this is the equation. Yeah, with this exactly the same as slope and intercept here, right? And we get the R square directly here. Oh, nice. Yeah. It is exactly the same as this one also. You see, this is the slope and intercept. Yeah. Put the green here for the blue. Okay, so is there any question? No question at all? I don't know if your question means you understand or you don't. Okay, so should I continue or should I wait for your question first. Well, you already learned this in other courses, then we can continue. It's fine.
Yes, Prof. We can continue.
Good, good. Let's continue then. Where are we? Here. So let's continue with the curvilinear transformation. Okay, so if you have certain non-linear like this, okay, you can actually convert them into linear model. Okay, and to convert them into linear model, you need to remember, okay, high school algebra. Yeah? Okay, the power of rule and the power of the logarithm rule. Okay, and from there you can convert, okay, the non-linear transformation, okay, from non-linear model into linear model. Yeah. Again, the t statistic and r square will not change by the transformation. Yeah. And if you want to get it, okay, this is the table that you probably will use often. Okay, so okay, let's do it in whiteboard. Let's do it in whiteboard. Where can I get to? Oh, why the whiteboard is not white? Okay. Okay. Great. Can you see the whiteboard?
Yes, we can see, Prof.
Okay, okay. So let's make a model that we will use. Which one you want to me to derive? Say, let's start with this one here. Y equal to the first one. Y equal to a x exponent b. Right. So this is nonlinear model, right? So what to do about this? So we take the can you make it into linear, Sophia? Hmm? Yeah, you can. So here I will put it log of y equal to log of a x exponent b, right? And then this one equal to log a plus b log x. Is that correct? Is that correct? Then we can keep names. Yeah, this one is the new y. Okay, this one is, I call it alpha. So this is the capital Y. You can make it. And then B is the same as beta. And then this log X is the same as capital X. Oh, it's a linear model, right? It's a simple linear regression. Can you see that? Okay. Well, alpha is log A. And then beta is B. Okay. So my question, let's practice this. Okay, using this one, can you get beta is the slope, alpha is the intercept, right? Correct? So then you can get back, no? What is A in here? A is, for example, this is log 10, so 10 exponent alpha, correct? Okay, let's do it in Excel. I will close this whiteboard for a while. Let's do it in Excel. Again, we use the same data, okay? Where's the data? Okay, this is the same data that we have. I just created new sheet here. Okay, and then format it to look nice. So you want to have y is equal to ax exponent b, right? And then a while ago, yeah, we said that the y, or the new y, is actually log of the small y, right? And then the new x is the log of the small x. Oh, this is the small x, this is the small y. Then we need to have the capital X, which is the same as log of x. And then we have the capital Y, is the same as log of small y. So this is how you do. So just take log, okay, log 10. Okay. Log 10 of x, okay, and log 10 of y. Okay, and then what you will get? You will get the slope, nah? The slope and the intercept. Yeah? Intercept. The slope of what? The slope of the capital X and capital Y. Yeah? Slope of the known Y, this one, and the known X. Okay? And then the intercept, again, the intercept of what? The known Y and the known X. Okay. So once you have that, what you will do? Remember the slope in the whiteboard a while ago? Okay. So the slope is P, right? So if we put here a while ago, P is equal to beta, yeah, which is equal to slope. Yeah. But alpha, okay, is equal to, oh, our model is become like this, right? Y equal to alpha plus beta times x, isn't it? Okay, so the slope is actually in here is the same as beta. The intercept is the same as alpha. Right? But you don't want to get the alpha and beta. What you want is actually A and B, isn't it? Okay. So okay, alpha is equal to 10 exponent of A is equal to, A is equal to 10 exponent to alpha, right? So then beta is the same as B, so I get equal to B here, but I need to get A. Okay? So B is just the same as this value, but A is equal to 10 exponent to this intercept. Yeah. So this one. Yeah, because this is linear model, so practically this is not so useful. You can try to practice using the model which is actually nonlinear. In the screen. Okay, so I have a data here which is actually not nonlinear. Can you see? So this is the x and this is the y. Okay, so if you want to get the power curve, logarithmic, and square root curve, okay, all you need to do is, okay, get back to this table. Yeah. So say this is the model that you have. This is the transformation that you have a while ago. So you take log, okay, and this is the alpha and beta that you get. Okay, so let's take example of this data. Okay, and I use the power curve here, right? So this is the linear model. Okay, so y is the capital Y here is the log y, the small y, and then you take the log in the right hand side, and then you can put it out. So log A here is the same as alpha, B is the same as beta, log small x here is the same as capital X here. Then what you need to do is to get the capital Y and capital X here, which is log X and log Y. Okay, and then you get the slope and the intercept here, which is alpha and beta. From there, you can get A is equal to 10 exponent alpha, yeah, which is this value. So if you take the regression, it is a linear regression if you take the log X and log Y, if you scale it. Okay. Say, take another example using the same data. If I use the model of ln AXB, okay. So what we have, we put Y, okay, capital Y here is the same as the right hand side, Y. And then because this is already ln, right? So we can expand this one, yeah? This is the same as ln A plus B ln X, okay? But ln A here, I can substitute as alpha, B I substitute as beta, and then small ln X here as capital X, okay? So what we'll have? So we have the Y, which is the same as Y here, so we don't change at all, okay? All we need to change is the X, the capital X here we change into ln X. So in that case, I created new column of ln X, okay? And then I create the slope between the ln X and the Y. And the same thing, I created the intercept of the ln X and the Y. Okay, this is the slope and the intercept. Okay, and then you get back. Yeah, you get back the actual value. Yeah, because this is ln A is equal to alpha, then A is equal to E exponent alpha. Do you want to practice this? Do you want to practice this? Is this confusing? Okay, let's practice. Okay, so that you will not. Okay, okay. You probably don't understand. Okay, I can see from your face. Okay, let's do it in Excel. Okay, I created new sheet. Okay, copy the data a while ago. So I have X, okay, small x, and then Y. Okay, what is the data? 7, 14, 24, 30, 45, 57. Okay, so that you can get exactly the same data as the slide. 24, 34, 45, 50, 61, and 69. Okay, which nonlinear model do you want to use? You can choose. Then we can practice. Tell me.
Prof, maybe not something involving logarithm so we can be reviewed or refreshed
Okay,
about its
okay, okay.
properties.
The logarithm. Okay, so uh let's do two practice now. One is the power curve and then the logarithm. Is that okay? Okay, so I will put here. You see, say I have a new model. The model is y equal to a x exponent b. Is that okay? The second model, this is called power curve. Okay. The second model later, we will do here logarithm. Okay? The logarithm, the formula is, what is the formula? Y equal to ln of a x exponent p. Okay. Okay, so we will do two model. Okay, let's do the first one. Okay, so you have this model. I copy here. Okay, so what you will do, you need to derive. Okay, so how to derive? The left hand side, it should be equal to the right hand side, right? So to derive this, you take the ln, for example. Okay, this time I use ln of the y should be equal to the ln of the right hand side, which is a, okay, x exponent b. Okay, so the left hand side does not change, but the right hand side I can expand. So I copy here. Yeah, the right hand side I can expand this, which is the same as ln a plus ln this one. All right. Again, because exponent, okay, I can put down, right? So in this case, I copy. This is the same as b, okay, multiply ln x. So up to here, is it clear or not? Now, I will say, look, I created new variable y, okay, equal, okay, alpha plus beta multiply x. Okay, notice that this is capital Y, okay, alpha beta x. Okay, if you don't like alpha beta, I will put it like this: C M. Okay, probably this is better. Okay, mx plus c. Mx plus c. Okay, so this is our new model with this linear. So in that case, y equal what? Ln y, isn't it? And then how about x? The capital X is the same as ln the small x. Yeah, the small x is this theta. Yeah, this is the small x, this is the small y, this is the theta that we have. Okay, so let's color the theta, right? Color the theta into yellow. Okay, so then we have m is the slope, isn't it? The slope is the same as b. Yeah. And then c is the intercept, is the same as ln of a. Okay, but later, okay, so I will put here. Later, you will see what we want is not c, what we want is actually a, isn't it? So a is equal to exponent of c. Ayun. Exponent of c. Okay, now we are finished. So what we will do? We created x and we created y, isn't it? What is x? Again, I just copy here. X is just this one, right? X is just ln x. How about the y? Y is this. This is the one. Yeah, I just copy here. Okay. So how to get that? Easy, just ln, right? Ln of what? X. Here, ln of the x. Yeah. Okay. And then because this is ln of the y, I just copy. I got everything. Yeah. Okay. Up to here, is there any question? You can get this, right? The ln of x and the ln of y. Why? Why we want to get ln of x and y? Because of this, yeah, the derivation. Where it come from? From here. Okay. Then what you will get? You will get slope and intercept. Right. You get the slope and intercept. So what is the slope? Yeah, just slope. Right? The slope of, remember the slope is known y and known x. But the known y is actually this capital Y. Yeah? And then the known x is this capital X. Okay. The same thing here. Okay. The intercept, yeah, intercept is the intercept of what? Intercept of this capital Y and then capital X. Okay. Oh, I got this value. Okay. Hey, the slope is the same as M, is the same as P, isn't it? But the intercept is C, right? The intercept is the same as C. But what we want is not C, what we want is actually A. Right? But we already know, yeah, because C is equal to ln A, then A is equal to exponent of C, isn't it? So then you can just exponent of the intercept. There, you get this value. Okay. Oh, and this is the value. Oh, okay, you get this value. Okay. So now if we plot, okay, I will show you if we plot this one. Okay, I go to insert plot, right? There, I plot like this, right? And you are using the power curve, right? You are using this power curve. So what you will do? First, I will check, yeah, whether I get the correct A and B or not. Okay, so what I will do is I right click here at the trend line, and then I use the power curve, right? And display equation and the R square, right? Oh, can you see? I got exactly this value A and slope. Can you see that? Nice. Yeah, I get the slope. Okay, it's not the intercept, but the A. Yeah? A is 9.0334. Is that okay? Now let's do the second one. Okay, let's do the second one. Which is the logarithm, yeah? So that you can see the contrast, yeah? Okay, so that you can see the contrast. I copy here. Okay, copy this. Can you see it? So then this is already logarithm in the right hand side. Okay, so in that case, I can just expand it the same as the power curve a while ago, right? So I just copy. This is the same as, okay, ln A plus ln of x exponent b, right? This is the same as, okay, b multiplied by ln x. Okay, I got that. So our goal is to create this linear model, isn't it? Our goal is to create this linear model. Again, I name it mx plus c. Okay, but now the y is not the same. Okay, the capital Y here is the same as the small y, isn't it? Can you see? Can you see the contrast? This one is the capital Y is the ln y, the left hand side. In here it's just y, the small y. Okay, the small x here. Oh, that one is ln x, nah? Ln of the small x. How about alpha or the intercept? And the intercept c is the same as ln a, right? And then the m, the gradient of the slope is the same as p. Oh, then because c is ln a, okay, so I have the same exactly like this. No, I just have the same. Oh, okay. So what I will do with this? Okay, now I copy the data here. Okay, I copy the data here so that you will see. Now I have different x and y. This is the capital X. This is the capital Y. Okay, the capital X is the same as ln x. This capital X is actually the same as ln x. The capital Y, in this case, I just copy here, small y. And then this one, what is this? This is just ln of the x, yeah? So this is copy. Okay, this one also copy. Can you see the difference now? Okay, it's not the same, right? The y is not the same. Okay. So then you do the same, nah? You do the slope and the intercept. Okay. So again, I use the slope and intercept. In here, I just copy. Yeah. Oh, let me check. Is it correct? Oh, correct. Yeah. Let me check the intercept. Oh, also correct. Yeah. Then this one also correct. Yeah. So Then I get this result. Okay, to check whether this is correct or not, let us do this. Okay, so plot in X, Y here. Okay, then I click at trend line. This is logarithm, isn't it? Okay, so set equation and display R square. There you get it. Oh, this is exactly this value, yeah? 21 and the intercept. Oh, why? Because this is the logarithm is directly here. Yeah? The intercept is 20. This is what one that is negative 20.25. Because the model is not like this. The model is like that without the A here. The loan is, this is already loan. Can you see? So that's why they use, in Excel, they use this one, not this one. Because the model is a little bit different in this graph and this one. But actually, they are actually the same model. So, up to here, is there any question? Is it clear or not clear? Question?
So basically, we're just simplifying the representation and then substituting back.
Non-linear model.
Mhm.
Substituting back.
Mhm.
Okay. So, in Excel, you can only have those, what is that? Logarithm, power, right? And then exponential is the three that you can put in. Yeah? But the others you cannot. For example, the square root you cannot. Then you can do it on your own. Yeah. Okay. So for square root, so can you see here? For the square root example, the exponential power and logarithm is already inside Excel. Okay. But this one, the others are not. Okay. From the square root, reciprocal are not there. So you can create on your own. Okay? So let me take example here of the square root, right? So what you will do, okay, say this is the model that you have, okay? So you just transform it, yeah? The y-axis is the same as y, but the x-axis here is the same as square root of x. So then you can get the transformation, yeah? The alpha is the same as beta, which is the slope and the intercept, right? So with that, you can use this, no? So you get the slope and the intercept. All you need to get is actually only the square root of x, isn't it? Instead of x and y, okay, now you use square root of x and y, okay, to get that. Is it clear now? Okay, can you summarize what you have just learned? The same is harmonic, the same thing, yeah? So all you need to do is just to take, say, this is 1 over y, the transformation, right? So, uh, so then after the transformation, you get exactly the same, yeah? So all you need to do is to transform it into linear model, that's all. Yeah. Okay, up to here first. Is there any question? Getting harder and harder after this. Question? Can you follow? No problem, yeah? Oh, the student very good, yeah? Okay, good. So now, okay, if you think something hard, you can interrupt, okay? So the next part is a little bit harder, a little bit only. But once you learn this, you will appreciate a lot. Okay. So let's come back to the simple linear regression. Okay. So this is the simple linear regression, right? Remember, our model is actually linear model, very simple. Y is equal to mx plus c, right? M is the slope, and then c is the intercept, yeah? So let's list for each data, okay? So you have the first data, which is x1 and y1. So that means you have m, okay, times x1 plus c equal y1, right? M multiplied by x2, this is the second row of the data, and so on, yeah? So if you look at this, okay, we can put this into matrix, yeah? So we can put this into matrix like this, yeah? So this is the x1, x2 until xn, okay? And then c here is actually 1, 1, 1, 1, 1, 1, 1, okay? So then you can put it, the one that you want to know, which is m and c into a vector, and then the output y1 until yn is the data again. Yeah? Remember, x1 until xn and then y1 until yn is the data. Okay. So if you look at this matrix form, okay. So what I have is this is the x a while ago, right? And then 1, vector 1, and then you have p is the m and c, okay, and then this is the output, yeah, the y, okay, x is the input, isn't it? If you look at this form, this is very simple, yeah. What is this? This is simple, what is called linear equation, right? A times b equal y, yeah. We learned this in high school, isn't it? Yeah. But what you learn in high school is only square matrix, yeah. But our model is regression, so the matrix A is not square, yeah. Okay, so how to solve this? Okay, how to solve this? So A is not square, so because A is not square, so no inverse, isn't it? Okay, so one way is to trick, yeah, using matrix multiplication, yeah. So we have, okay, let me do it in whiteboard so that you can get it. Whiteboard. Where is how to create a whiteboard? Okay. Alright. Can you see the whiteboard? So this is our matrix, okay? A, oh, okay, so I have matrix A times vector B equal Y. Right. Remember, matrix A is not square matrix, so you cannot find the inverse. Right. So our way to do is you put equal in the middle, okay? And then we multiply in the right side, yeah, with the transpose, yeah. With the transpose of A multiplied by A times B, yeah. And then because you multiply with the A transpose on the left side, then you on the right hand side you also multiply with the same thing, yeah. A transpose times A. Why? Why we want to multiply by A transpose? Because A transpose times A will become square matrix. Okay, so this is a square matrix. This is a square matrix. Clear? Up to here, is it clear or not? So, because this is a square matrix, we can find the inverse. Okay, hopefully. Okay, so then we will put the inverse, which is A transpose times A inverse. Yeah, so yeah. Okay, and then A transpose times A. This is just copy, yeah, and then the equal is still here because I multiply by A transpose times A inverse. Okay, in here also A transpose times A, okay, inverse, and then I just copy again, yeah, A transpose times, oh, this is Y. Where is the eraser or delta eraser? I will erase this. This is Y. This is Y. This is minus 1. A transpose times Y. Is it clear or not? Up to here. But something inverse multiplied by itself. So it's basically identity matrix times P equal to, yeah, this one. I call this L times Y. So P equal to L times Y. What is L? L is A transpose, yeah, multiplied by A, right? And then I take the inverse times A transpose, yeah. So this L is called generalized left inverse. Using this, you can solve any regression. Any regression. Okay. So to here first, is there any question? Look like very demanding, yeah. Very long equation, isn't it? A transpose times A, and then you inverse, and then you multiply again with A transpose. But that's easy. You can do it. Okay. In Excel, yes, you can do it in Excel. Take a note of the L. Is that okay? Okay, let's come back to the slide. Okay, so I will close this one. So this is the one I just derived a while ago. Okay, so B is equal to L times Y. Okay, so the solution of AB equal Y is B equal L times Y. Yeah, this is generalized inverse. Yeah. So you can use the general inverse for simple linear regression, for multiple linear regression, for polynomial, for classification, and so on. Okay. So how to do it? I used the same data a while ago. Okay. And then all you need to do is to create the matrix A, and then you get the transpose, and then you multiply A transpose times A, and then you take the inverse, and then you get the L. Yeah. After that, you multiply the Y is just copy of the Y, and then you can get the P. Okay, let's do it. Yeah, let's practice this using our data a while ago. Yeah. Excel. Share. Okay, so I copy the data from the growth factor a while ago. Control C, yeah. And then I create the new sheet here. Okay. And I format it. Okay. There. So this is our X. Okay, and this is our Y. Okay, let's do it a simple linear regression, yeah. So Y equal to MX plus C, right? I know you can do it in Excel very fast using slope and so on, but let's do it in matrix so that you will know how to do it. Because once you know this, you can do the others. Okay, so what you will do? First, you will create matrix A. Okay, what is matrix A? Matrix A consists of, okay, in this case, matrix A consists of X and 1. Okay, so what is X in here? And this is 1. Okay, so X is just this X. Okay, I just copy how many? 5? Oh, one more. Okay, and then 1 is just 1. Okay, so this is matrix A. Let's color it. Okay, so this is matrix A. To name matrix A, I will type here MA. Is that okay? There, I keep name matrix A. Yeah, MA. Up to here, is there any question? Can you do it? Is this too fast? Can you follow? Just copy, right? This is just copy from the data. Yeah? Okay. Matrix A is just the year, the X here, and then all 1 here. Is that okay? And then all you need to do is to keep name. Yeah, this one matrix MA. Okay. So I have MA. Next, what I will do, I will create matrix A transpose. Yeah. So this is A. I will create A transpose. A transpose. I will put A accent like this. Okay. So what I will do, I will just put transpose, right? Transpose of what? Transpose of A, right? Okay. So if I want to put transpose of A, just copy. Oh, it's still value, no problem though. Huh? Okay. So all you need to know is the size. Yeah. What is the size of this A? Size is how many? 5, 2, isn't it? 5, 2. Yeah. Correct? The size is 5, 2. Okay. So in this case, the size of transpose is 2,5, right? It's transpose. So yeah. Marie Chris, you have a question.
So where did you get the 5 and the 2?
Oh, okay. 5, 2 is here. 1, 2, 3, 4, 5. 5 rows. Okay. The size is always, okay, size is always number of rows, comma, columns. Yeah. The size is always like that. So then remember the most important is to know the size. Okay. If you give a wrong size, you cannot get the result. Okay. So now I have 2 by 5. So this one 2 by 5. 1, 2, 3, 4, 5. Correct? Okay. Can you select 2 by 5, the size? Okay. And then what you will do, you click this one. Okay. Okay. And then, okay, hold shift key and enter together. There. Okay, I will type here so that you will know. Okay. So you can edit. Oh, wait. Select. And then edit. Yeah. Have to. And then let's curve together. Yeah. These are the steps. Okay, I want to make sure you can do this. So you share your screen. Okay. Okay. Can you just get the A transpose first? Because if you cannot get this, you cannot follow the next step. I will wait. You do it and then you share your screen. Yeah. Who want to share the screen? Two of you. This one you give name. Yeah, it is A transpose. So I will get M-A-T. So transpose, yeah, and matrix A transpose. So I give name there. Okay, until matrix transpose pass. Is there any question? Is there any way for you to share your screen so that we can go in the same pace? Let's see. Okay, you share your screen. To because I will stop my sharing. Let's see you share your screen. You can also get recitation when you share it. Okay, so okay. Can you go to L1? Can you go to L1? Oh,
No.
why it is not matrix? Okay, can you start again to get that matrix L1? Okay, so this is transfer MA. Okay, so you get it. So how about the others? Can you also share your screen? Okay. Who want to share screen? One more. Come on. I want to make sure at least two of you. The boys. Oh, okay. Okay, okay. Katrina, you want to share screen?
Okay, but
So,
I'm trying to display the transpose matrix.
okay. If anyone have problem, you can also share screen. I will help you.
Prof, I already
Okay, that is good. Okay, so that is good. Now you need to know the size. Okay, can you use your shift key, hold the shift key, and then use your arrow to create the number of size, the correct size. Yeah, use your shift key, hold the shift key always, and then yeah, go there, and then use your shift key, and then go to the right, and then down. Your arrow key. Yeah. Until the size is 2.5. Or you can use your mouse. That's fine also. You can drag your mouse. Until there. Okay, good. And then you go up there to the
here.
yeah, the formula bar. Can you click okay? And then now you hold your shift and control and then enter together.
Sorry,
Okay. First you hold your shift and shift control enter.
Shift control enter. Okay.
Yeah, you got it.
Okay.
Okay, good. Okay. So anyone have problem? You want to share screen? Okay, I will help you. Come on. Okay. So in Excel, if you are dealing with matrix, that is how you do, yeah. Shift control enter. Okay. Anyone want to share screen? One more. If you have any problem, so that I can help you. Come on. Abi, you want to?
Sir, I already did what you
You
taught
already did.
us. Yes, sir.
If you are using MacBook, okay, you probably get automatically, so I don't know. Okay, and
Yes,
then the
sir.
Shift Control Enter is probably also different a little. Okay. Okay, good. So, is there anyone want to share screen to get just the transpose? No problem. Everyone can do it. Okay, so in that case, let's continue. Let's continue. Sorry. Okay, okay. Let's continue with the Excel. Can you see my Excel? So our formula for L, remember L, the generalized inverse. Okay, so I will type here L. Generalized inverse is the same as A transpose, yeah, times A inverse, okay, times A transpose, right? Okay, I'll just remember this. So in that case, I need to multiply A transpose times A, isn't it? Is that correct? Okay, then let's do that, huh? So I have here A transpose times A. This is matrix multiplication, isn't it? Okay, number one, you need to know the sign. Okay, let's go. A transpose is 2, 5, right? 2, 5 by A is 5, 2. So the result is, what is the result? 2, 2, yeah? The result and the last one, yeah? Okay, matrix multiplication, the inner one, okay, the inner one must be the same, yeah? This one must be the same, otherwise you cannot multiply, yeah? So I put that as B, then M mole, there, M mole, right? M mole of what? A transpose, this one, comma, yeah, A, there, okay, just like that, and then you close the parenthesis, okay, and what you will do, 2, 2, you highlight, you get selected 2 by 2, and then again you click here, and then Shift Control Enter, there, you get the result. Ta-da. Okay, next, we want to get inverse. Yeah? So we want to get the inverse. Maybe I need to put it this way. Inverse of, yeah? Inverse of this one. So this is matrix inverse. Okay, so I need to get the inverse. Yeah? Inverse of A accent cos. Remember, matrix inverse is the same size, right? Okay. Oh, what happened? Can you see? So I get the inverse, and I need to multiply one more, right? With the to get the L, I need to multiply one more with the A transpose, yeah. So I need to get the L. Shall I put it here? L. Oh, if I want to go to L, so I need to know the size. Remember, the most important is the size. Yeah. So we get the 2. Yeah. This one is size is 2 by 2, right? So what is the size? Oh, I need to multiply by A transpose, which is 2 by 5. So I have 2 by 2 multiplied by 2 by 5. Okay, then equal to 2 by 5, right? So why? Because this is the one that we need to get. Yeah. Okay, so the initial and the end. Yeah. So the size must be 2 by 5, the same as the A transpose. Okay. Once you know the size, you just multiply, right? So what you will do, M mole. Okay, M mole of what? Of this one. And first, and then with the A transpose. Okay. Okay. Then the size must be 2 by 5. Okay. Once you have this, what you will do? Shift, Control, Enter. Oh, I got that. Okay. This is the final result. It is the generalized inverse. Okay. Generalized inverse. So, once you get the generalized inverse, what you will do? P is equal to L times Y, right? So we know that P equal to L times Y. Okay. So the Y we already have this one, right? So I will just copy, yeah. So the Y here is just copy of this population. Okay, 1, 2, 3, 4, 5. Is that correct? Okay, so let's name this Y. Y underscore. Okay. So this is again just copy. Then I need to get the B, isn't it? The final result is the B. Okay. Factor B is what? Is this one. B is basically the same as M. The size is 2, 1, right? Okay, so B, okay, let's get the size first. B is L times Y. The size of L is 2, 5. Okay, the size of L is 2, 5 multiplied by the size of Y is 5, 1. Okay, then the size of B is 2, 1. Okay, so I need to get the B. How to get the B? M multiply, yeah, M mole. M mole of what? L. Oh, I did not keep name here. So let's keep name this one, yeah. This one L, ML. Okay, so then I will have here M mole of ML, this one, comma, what is that? Y. Yeah? This is the Y. There, I got that. Right? So what I will have is, again, the size is 2, 1. So you highlight, okay, you edit, Shift, Control, Enter. Oh, this is the final result. Oh, okay, this is the final result, yeah? Is this the same? 81371. Oh, exact the same, yeah. Good. See, this one is matrix. Yeah? Matrix. Hmm? Where is the matrix? Oh, this one. This one is the matrix. Sorry. So, is there any question? Do you want to share your screen? I just want to make sure that, okay, two of you can two of you share screen? Yes, Sophia. Okay. So, two. Okay, Sophia. Co-host. Go, Sophia. Oh, super. Yeah, you got it. Okay, very good. Okay, one more. Yeah, thank you. Easy, yeah? Easy. One more, one more. Who want to share screen? You can claim your recitation. Oh, Joshua, Andre, Nina, or Marie, Karunungan, or Katrina, Paolo, Bien, oh, come on. Jerome, Jofi, Christine. Anyone? Did not decide yet today. Come on. Can you get the result? Oh. Oh. Okay. Okay, you can okay, give a chance to others. Okay. So, but who did not recite yet? Come on. Okay, Katrina, you can recite. No problem. So, generalized inverse, no problem. Yeah. Okay. Using this, you can create any matrix. Okay, based on your data. Okay. Okay then. If no one want to share, I will come back to the slide. Okay. Now let's go a little bit further to what is called multiple linear regression. Okay, a little bit further. So this is the one that you will use in trip generation later. So in here, I give you very simple data. Okay, so this is in pesos, the price. This is based on real data. Okay, so say I have a data from second-hand car, say same car, same type of car. Okay, say for example Toyota. Yeah. So and then the age is in month, and then the kilometer. Okay, and then this is the price in pesos. Okay, and we want to estimate the price. Okay, based on this model, which is A plus B times age, the month, and then times C, the kilometer. Okay, so only two factor, which is the age and the kilometer. Yeah, this number is 1 to 10 is just number of data. Okay, so the question, can you get the B and C, and then can you get the price of the new car, which is A? Yeah. So once you type this into Excel, okay, and what you do is to create a matrix, right? So how do you get the matrix? This data, yeah? Age and kilometer, okay, I put it here, independent, and then you need to have intercept, right? So the intercept, I put 111 in here. Okay, so intercept itself is a variable, but the variable is 1. Okay, and then the dependent is the price. Okay, so and then so the y, this one is not p, not p. This is y. This is should be y. Yes, Marie Grace, you want to ask something? This is not the p. This is should be y.
The value
Hmm.
of the intercept, we always use 1 or
Correct.
that change.
Always 1.
It's always that. Okay. Thank you, sir.
Why 1? That's a good question. Yeah. So actually this is a times 1, isn't it? Okay. So the variable you need to put coefficient times variable. So you don't have the variable in here. So this is basically 1. Right. Okay. The intercept is always 1. That's correct. Okay. So now, depending on how you put the intercept, you can put it in the beginning, you can put it in the end, or you can put it in the middle if you are making yourself a trouble. Okay. So it's up to you. But you remember this represents something that you put in the variables. Nah? So here, can you see? I put it 1 in here, A, and this is the data a while ago. And this is again the data, Y. Okay, these two here. This is the age, this is the kilometer, yeah. Okay, and this is for the intercept, I put 1. And from here, what we will do, we will do exactly the same. Yeah? We will do A transpose, right? And then A transpose times A, and then you take the inverse, and then you get the generalized inverse. Remember the size important, yeah? The size must be not the same as before, right? Because this one have 3 columns, so this one have 3 rows, yeah? And then finally, you will get the B here. Yeah? This one is the A, B, C. Yeah? Okay, A, B, C. Up to here, is there any question? Is it clear or not? Can you get this? The same technique as a while ago. Hey, can you see the value here? 900,000 something. What is that? What is that 900,000 something here? And why this one is negative? Why this is negative? Okay, so 900 something, Okay, if this is the model, right? So if you look at this, okay, this is the model. That means when age is 0, kilometer is 0, okay, so the price is equal to 900,000. So that is the price of the new car, isn't it? Right? So why this is negative? Because as the age is, that your car is aging, right? Meaning that you are already using, okay? So then the price goes down, okay? Okay. So this is the slope for the age, and minus 20 is the slope for the kilometer. Okay. Once you get the estimate, right, then you can check the error. Yeah, you can error is just the estimate multiply minus the price. Yeah. So this one is negative. This is positive. Okay, with that you can predict, right? How do you predict? Well, you just input. Yeah, you put the age and the kilometer here. Okay, how do you get? You will get. So this is the model. Yes. Once you get the model, you just input the age is 21 months, and then the kilometer is 41 something. Oh, it's 6 dealer now. Okay, using the data you can. Okay. So once you have the data, you get the model. Once you have the model, you can predict. Yeah? Okay. Is it nice? Yeah. So in the regression model a while ago, yeah, y equal to price of used car, okay, and then x1 is the age car in the month, x2 is the mileage, right, in kilometer. So this is the actual equation, right? So I can put it x1 and x2 or age and kilometer. So given this equation, can you get the dimension? Okay, can you get the dimension? And then can you interpret the meaning? And then can you get the range of value and the sign of each kilometer? Oh, remember when you do modeling, okay, it's important to understand the dimension. It's important to understand the valid range, right, of each parameter. Okay, kilometer. So what you will do? Okay, so I have price. Okay, A plus B times 8 times C times mileage, right? So the price in pesos or in dollars, so I put in dollar here. The A I don't know, B I don't know, 8 is in month, right? And then C I don't know, mileage is in kilometer, right? So the unit, yeah? The unit is kilometer, month, and money. Yeah? So now let's get, if the H2 is 0, that the mileage is 0, and then X1 is also 0, that means the 8 is also 0. Okay, that means I have price equal A, isn't it? Huh? That means I have the new car. Eh? So A, the unit of A is in dollar. If this is in peso, this is also in peso. So now I can put X2 as 0. I know already this is in dollar, this one in dollar. Now if I put this in 0, what is the unit of P? Oh, because this is in month, then the unit of P must be in dollar per month, correct? Yeah. And the same thing, if I put the H is 0, okay, then I have A and C only. Then I have C uh, is dollar per kilometer, right? So I know now the unit, yeah, for its coefficient here, A, B, C. Okay, and check if you multiply all things, you get equal. Yeah. So then the meaning, this is just the gradient. Yeah. So this is the A is the price of new car, B and C is the gradient or the margin of the price by the age and the mileage. Okay. Now, if you want to know the valid range, then you need to assume something, right? So the more use, the price must go down, isn't it? Okay. Then you know the sign of A must be positive. The price of new car must be positive, right? Cannot negative, cannot zero. Other is free, right? From your uncle, yeah. Okay. So then sign of P, yeah, when you use more, okay, this one must be negative. Sign of C also negative, yeah, because when you use more, the gradient must be negative. So that based on the meaning, yeah, of the parameters, yeah. Okay, and then now you need to assume something to get the valid range. So assuming the used car have no more value after 15 years, that is 180 months, or after say 5 million kilometers. Okay, this you don't like this number, you can change it. Okay, so I just making this number up so that we know this is quite big number. Okay, then we can, because we know the extreme big number, then we can put into the equation, okay, to get the value, the extreme value of B and C. Yeah? So can you see this? You put 0 equal to A plus 180 months of B. In that case, B depends on A, yeah, negative. And then if you put B 0, only C, then you get C is depends on A. Remember, A is the price of new car. Okay. With these two, you can get the valid range. Nah? So B is between 0, because B is always negative, between 0 to negative A over 150. And then C, the parameter C, is between 0 to negative A per 5 million. Yeah. So again, value of A, you can just visit the car dealer. Yeah? Oh, up to here. Did you learn something? Yeah. This is the power of modeling. Yeah? You can predict.
I have a question, Prof.
Oh, go.
What if your assumed sign is wrong?
Wrong.
Mhm.
This is what will happen. I will show you in a moment. Yeah. So yeah, this one.
Okay.
Okay. So this is to answer your question. Okay. So in modeling, okay, you divide the variables into two. One is called policy variable. That means variable that you know by your knowledge that this must be there. Yeah. Or policy variable is the variable that you want to control. Example, in transportation, usually the one that you want to control is the cost, maybe the tax, yeah, the price of the transport cost, example, yeah? Or the distance, okay? Or the time. Okay, so these are the policy variable. Okay, and other variable, for example, comfortability, convenience, and so on. So these are other variable. Okay, yeah. So you divide, yeah, two type, yeah, policy variable or other variables. Okay, this is one. Second, you can use the t-test. Okay, the t-test is significant or not significant. How do you know? Significant means the absolute value of the t-test must be larger than 1.96 a while ago, yeah, or 1.65, 645 for 10% error, yeah. So this is from the t-test, yeah. This one is from the your knowledge, yeah, in the domain, and the sign come from the regression or the model that you adjusted. Yeah? So what happened if this is correct sign and significant? So of course you include that policy variable, no? And then other variable, of course you include. This is no problem at all. So Katrina was asking what happened if the sign is wrong. Okay, then check the t-test, no? Significant or not. Okay, then you check whether what is the variable here. Big problem is these policy variables. Okay. If it is other variable, you just reject, meaning don't include in your model. Yeah. So if the sign is correct, but the theta is not significant, but this is policy variable, you still include. Okay. But this is not not significant, then this is other variable you may reject, meaning you don't include in your model. Modeling is an art, you see. Okay. So I just give you clue here. Yeah. Which one to include, which one to reject. Okay. You will have problem if if it is policy variables, okay, and you have a wrong sign. Then you probably want to change the model. Okay. Marie Grace, you want to ask question?
So basically, sir, when we get the wrong sign, it's more or less rejected already because
Correct. But
we did something wrong. Okay.
depends. Rejected can be that variable is rejected or the model is rejected.
Okay.
Meaning
But
you probably this model probably not linear, probably non-linear. So you need to change the model. So,
okay. Okay. Thank you, sir.
okay. So this is the big problem here. Okay. Any other question? So this is the practicality. Yeah? Again, modeling is an art. Okay. So you still use that those indicator like R square, t test, and so on. But at the same time, okay, which variable to include, which variable not to include, this is you need to check. Yeah. Next. Okay. They have say how many n variable of x. Okay. And this is what you will do. Okay. First, you need to list the combination of the model. Because you list the combination of the model, what you will do is to check the correlation. Yeah. You don't want to have high correlation between xi. Yeah, between independent variable. But between y and x, yes, you need to have a high correlation. But between x itself, you should not have high correlation. Why? Because if you create input which is actually correlated, highly correlated, they are actually the same input. So you will have overfitting. Yeah. So you will get very high R square, but you cannot use for prediction at all. Okay. So again, the same thing as a while ago. Yeah? The t value, absolute value of the t for each variable, including the coefficient, must be larger than this number. Yeah, this magic number from the normal distribution. Okay, and the f, significant f was less than 0.05, and then r square. Well, for multiple regression, let's make it larger than 0.6. Okay, when you choose the best model, you get the highest r square. Okay, let me give you an example so that you will understand. Yeah. So I have only 4 variable x1, x2, x3, x4, and this is the correlation matrix. Can you see? Okay, and this is the combination list of all possible multiple linear regression, isn't it? Because I have 4 variables, so I have one variable 1, 2, 3, 4, and then 1, 2, 1, 3, 2, 3, 2, 4, 3, 4, right? This is the combination. And then 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4, and then 1, 2, 3, 4. Okay. So these are all possible combination, exhaustive. Okay. Now you check the correlation, yeah? Because what happened? Okay. So check the correlation between x1 and x3 is very high. The same thing with x2 and x4, which is very high, yeah? So that means they are actually x1 and x3 actually the same variable. The same meaning, this one. Yeah? The same thing with x2 and x4 are the same meaning, so they are highly correlated. So if highly correlated, what you will do, remove. Okay, look at this. The first 1, 2, 3, 4 model are deleted. Why? Because r square is less than 0.6. Yeah, this one. Can you see? Less than 0.6. So this one no more. Huh? Okay. And this one, 1 and 3 should not be together. Why? 1 and 3 should not be together because the correlation is very high. Yeah, higher than 0.8. So the same thing with 2 and 4. X2 and X4 should not be together in the same model. Why? Because they have high correlation. So all of these, can you see? 1 and 3, 2 and 4. This one is 1 and 3. This one is 2 and 4. This one is 1, 2, 3, 4. So this is all deleted. Okay. Now what we have is only 3 model. This one, the one in bold. Can you see it? So only the 3 model out of this list of combination that you can test with T, F, and R square. That's how you select the model. Yeah, if you use SPSS, this is already done automatically. Yeah? If you are using Excel, you need to do this alone, one by one. Okay. So with that, do we have all? Yeah. Okay, this is done. So is there any question? Yeah, very Chris.
Sir, this is related to the assignment.
Ah,
Can we just use any, like, can we just create the data? Because I noticed, I searched a while ago that we have to file freedom of information to get the LTO registration.
ah,
So it
yeah,
takes
actually data is not so important. Can you just get so that you will learn how to get the data? LTO registration is open the data. Yeah.
yes, sir,
Say for
but
example, not in Davao, you can get from Metro Manila is fine. No problem.
okay, so we can just use anything we can find on the internet.
Yes.
Okay. Because
The actual data is not important for me, but the practice to search the data is important.
okay, sir. Because I tried looking at the internet.
Okay. And then, yes. So once you search it and then you start to realize, oh, the data is messy, for example, then I need to clean it. That's exactly the one that I want you to
Yes, sir.
get. Okay. So put the citation when you get it, and then just do a simple regression. Okay, either multiple linear or just regression. And then this is just practice, no? Practically. Can you use matrix? Okay. So that you can practice. Okay. Or you can use polynomial regression. That's fine. Okay. So next week we don't have class, correct? That's your request, or you still want to have class? Hello?
Yes, sir.
Next week is November 3.
3. Yes, sir.
Do we have class or
Yes,
not?
sir. No class, sir.
No class. Okay. In that case, so November 10, you will have midterm in Moodle.
Yeah.
Okay. Open from 6 o'clock until night, so we don't have class at that day.
Okay.
But the exam itself is 3 hours. Okay, my question to you, you want 1 attempt or 2 attempts?
2.
2 attempts. Okay, I'll give you 2 attempts, no problem.
Sir, can we like open our notes for the exams for the
You
formula?
can open everything, open internet, open AI, open everything. I don't check you. You are mature already, so
I
right?
was just concerned about memorizing the formulas. So if we could
No,
have.
you don't need. So, and you have three, uh, I think I have like 10 to 12 questions, multiple choice,
Okay.
okay? Like the quiz out last time.
Okay, sir.
Is that okay? And then we will meet again on November 17.
Okay.
Yeah,
Okay.
okay. And one day before our meeting, you get to put the assignment forecasting. Okay. And I hope during that time on November 17, you will learn, you will read before the class about trip generation, distribution model split, and I don't know if we can finish the traffic assignment.
Okay. Yeah.
Okay.
Yeah.
So now the coverage of the midterm is from the beginning until today with this forecasting.
Okay.
Okay, so the trip gen is not included.
Yes, sir. Yes, sir. And
Okay, to attempt. So
yes, sir. And sir,
yes,
can you upload the lecture for tonight this weekend so we can review the recorded?
lecture. The
The
recording is I don't handle the recording. It's actually UP graduate studies is the one who so they will usually keep me on Monday. So
Okay.
you can remind them. You can remind them. Okay. Okay. Once they give me, I will put the recording in Moodle.
Okay. Thank you, sir. Thank you.
Yes, yes. So is there any question? Don't forget to claim your recitation. Okay. So see you again on November 17.
Thank you,
Actually,
sir.
we still have 10 minutes. So if you have a question, go ahead. Abi, you want to ask something? Or Christine?
Sir, I have a question regarding with our group.
Yeah, group project. Yeah.
Um, is there a tentative date for our presentation, or we'll just be
Yeah.
we'll just submit this?
Uh, the presentation you supposed to I think you have it. Uh, At first, I want to make it on November 17, but are you okay with that? Or
No.
no?
Huh?
The final presentation is January 5, but I want to have a progress presentation, like progress report, in November or December.
December.
Depending, Prof, what should we have covered by that time?
Oh,
Mhm.
by that time, your data must be there. Your scenario, base scenario, and alternative scenario must be there, right?
Okay.
So no, we just have to show the existing data and the scenarios we will consider. So are we
You
supposed
need to
to?
run it. You need to run it. You need to get the
Uh,
result already.
I see.
Okay. Let me share your screen. Something. I have in Revolution. Okay, let me share screen then. So here I have the ideal flow. So if you are not familiar with Python, I work very hard to make it so that you can make it. So this one, IFN transport, right? So say this is your example. Okay. All you need to do is just to do you download from OSM, you transfer the data into link ID and then start node ID, end node ID, and then link capacity, and then link distance and maximum speed. Okay. So, or you can just from the map, you can just dot by yourself. Yeah, this is the data that you will create. Okay, basically just link and node, right? Once you have this, you can display here. Okay, and if you uploaded your data, you can. This is an example. Yeah, I just once you upload the data, you can save as CSV. See, this is the CSV. Can you see the CSV file? Okay, so then you can upload that CSV file into this matrix here. This is the format. And then if you clear, see, I upload the CSV file a while ago. This one, right? There, it will come back. Yeah. Okay. And you can test if this is strongly connected or not. Yeah. So if strongly connected, it will say strongly connected. And once you have that, so you check the model here. Yeah. You can use maximum congestion, for example. Oh, maximum congestion. So I calculate there. Okay, you get the result here. Okay, so check the example here. For example, this example 4. Okay, if you look at the network, this is not strongly connected. Yeah, from left you can go to the right. You cannot go back. That means if you run the model, it will not happen. Yeah, it will say, oh, the model is not strongly connected. Yeah. Now, model example 3 here is actually in Katipunan. This is Katipunan area. This is the Ateneo inside the Ateneo to Manila. Okay, and here this model is basically this is the Katipunan area, and this is the bridge. Okay, and I just put this into a dummy node. Okay, and then dummy links here, and then I connect it to a cloud node, because if this one alone, this is clearly not strongly connected, so we need to add cloud node to make it strongly connected. So here, this is the cloud node. If I include the cloud node, you will see is the actual. Okay. So that I do this manually, so better using this network is created manually. Okay.
So what does the cloud node? Like you were the one who assigned the cloud node. So are this
Yes, you will be the one to assign the cloud node and then connect the cloud node to the source and the sink so
okay,
that it will become strongly connected.
okay. So these are basically like, for example, if you say Katipunan, this could be like one corner that turns to UP, another one we assign, those are intersections where the car can stop or move in another direction.
You can
Or
see
yeah.
this is not really, yeah, this is the intersection. The node is not necessarily intersection.
Okay.
Yeah,
Ah,
this one is not intersection. This is just dummy node. Yeah, this one is again like the source and the sink.
oh, okay.
Okay,
Okay.
this is connected to other. This is the one in, for example, Esteban Abada or something like
I
that. So I just put nodes here, and then this one all connected to the cloud node. Yeah,
okay.
this is the cloud, the one in Katipunan. Yeah, this is the bridge.
Okay. So
Okay,
that's basically where there
this is
are
going to Marikina,
okay.
18.
Okay. Okay, sir. Thank you.
Yeah, this is inside the campus, Ateneo campus. So I don't know. Do I answer it? So if you want to model the detail, okay. So if you want to model the detail, you need to go to this one. This is the detail inside each of the intersection. So, well, I did not. So basically, in here, you need to. In your case, you drag on the right. So, right. So if you drag on the right, so you check how many lane. For example, in the east. Okay, I'll put the setting with the center line and compass so that you see. Okay, so say in the east I add 3. Okay, the south 4. Okay. So you see if there is something wrong, it will give you warning. Yeah, there's an overflow.
Sir, can we change the sizes of lanes? Because, like, for example, in EDSA, we have a different size of lane for motorcycle, for cars, and for
The size of lane is basically not really the size, but what you change is actually the saturation flow, the capacity.
okay, sir.
Yeah,
Okay.
this is the assuming that the size of lane is the same now for all.
Mhm. So
And
basically, yeah. So
so I
basically,
use only 1.15.
okay.
Yes, sorry.
So basically, for this project, sir, with the IFN lab, we can already complete it. Like, we don't need to use GIS or other mapping techniques for our.
Yes, actually you don't need to. But if you want to have more, then you can add on your own.
Okay. Thank
Say
you.
one of you said, "Oh, I don't want to use IFN. I want to use JICA Strada." Is fine, no problem. If you have it, that's it. Yeah. So say you have your own software, yeah, expensive software, then you can do it. Okay. So if you don't have it, so I provide for you free of charge. It's the same thing. Yeah. Of course, the result is not the same. Yeah, but you can compare later on. Okay. Anyway, after the midterm, we will discuss more about traditional and IFN, more detail later, yeah, in November and December. Okay, I hope this is helpful. And this one, RLL is meaning the right, left, and straight, yeah. So this is the rule that you can define. Okay. Based on this rule, you can have whether this is enough or not, yeah, and which one is not enough. You will know for the intersection. So if you want to make it 0, then you will have what, T intersection. Right, so it's the same. Yeah, this is just to guess the flow. Yeah. If you use a traffic signal and so on, I did not make it yet, so you probably need to compute on your own. Okay. I hope this is useful. Yeah. Yeah, thank you for today and see you on November 17th. Yeah. Don't forget the midterm exam. You have 1 day from morning until evening. So if you forget, so it's your problem. Okay? Okay.
Thank you, sir.
Thank you.
Thank you.
I already got. When do you want the presentation? The progress report, huh? Not the end. The end is of course January 5. Okay. Progress report. At least one more time progress report. So either November or December. How about the first December? Is that okay?
First week of December, sir. It's okay.
No.
December 1st.
December 1st.
Uh,
Yes.
yeah.
Or too fast. If not, December 15 is fine.
December 15, sir, and then we just email you in between. So while we form our content
Okay. Then before December 15, okay, so this is the workshop. Okay. So before December 15, please make a one-to-one consultation.
Yes, sir.
Okay. Okay. Good. Thank you. Thank you.